So starting section 5.3, looking on page 289, we're going to take our time in this section to really hone in on these four important theorems that we've talked about so far in our calculus studies. So way back in Unit 1, we were discussing the intermediate value theorem. That was kind of our first intro theorem that we saw this year. And that was when we said that if we knew the outputs of a particular function and we had some other output that happened to be in between these two outputs from the endpoints of the interval, then we knew that there was some special spot between these endpoints that would give us that output of y. Okay, this was all the way back in Unit 1, if you want to go ahead and refresh your memory with that. More recently, though, we've been looking at the extreme value theorem and then Rolle's theorem and mean value theorem. So all of these are in this Unit 5 that we've been working with. So extreme value theorem, if we're continuous on a closed interval, we know we're guaranteed a max and a min, okay, absolute max and absolute min, and that can happen at an endpoint or a critical point. We kind of dealt with this theorem before break. And then after break, we've been looking at Rolle's theorem and the mean value theorem and how they're kind of connected to each other. They're basically the same concept. It's just that Rolle's theorem, we have the endpoints that are equal to each other, and for the mean value theorem, that's not necessarily a condition. The mean value theorem is simply stating that the instantaneous rate of change, meaning the derivative, would equal the average rate of change, meaning the slope between 2 points. So if you take a look at these four theorems, notice how continuity is a condition for all four. So having a continuous function is something pretty important that we need to analyze and make sure that is true for any function that we are dealing with. So we first of all want to make sure that we're continuous. Depending on the theorem that we want to use or we want to apply, sometimes there are additional criteria. For instance, having an output between the outputs from the endpoint or the endpoints. Maybe we have the endpoints having the same height. Maybe we need to be differentiable, okay, meaning no, don't include the endpoints. There's no sharp points. There's no vertical tangents anywhere. So all of these have to be continuous as a criteria, but there could be some other ones. So in this section, we're just going to take a look at a bunch of examples, kind of word problems, if you will, or free response type questions that are going to ask us to analyze these different theorems, but they usually, on the AP test, they don't identify these theorems by name. We kind of have to recognize which theorem they're talking about based on the question itself. So that's one thing that might be important for us to realize, that on the AP test, don't feel like it's necessary to name these, okay? As long as you can state the criteria or the conclusion, that's okay. I mean, it would be wonderful if you can remember the names, but if you don't remember the name, that's fine. It's just remembering or knowing what the theorem says is kind of the more important piece.